Okay, so like I told you guys, long division, same rules, right? Same rules that you learned back in 4th grade. These two problems I took from a 4th grade book, just to show you that it's the same steps we're going to use today. Okay? So there's two types of division I'm going to show you. The first one is long division. I always show you long division first because that's the one you're familiar with. That's the one that looks familiar, the one you've done before many, many times. Synthetic division is the new one, the one you haven't seen before. I'll leave that for Wednesday. Okay? So after I show you both, practice 12 is going to be long division, practice 13 is going to be synthetic division. After you finish practice 13 and we start reviewing, you can choose whichever method you like. You don't have to do. I want you to use, on practice 12, I want you to practice long division. And on practice 13, I want you to practice synthetic division so you learn it. But when we start reviewing and we take the test next week and it says divide, you can use whatever method you want, okay? Whatever method speaks to you, whatever method's easier for you, whatever method you want, okay? So that's why I show you two methods. They both work exactly the same, okay? All right, so here we go. Let's do this problem. So you guys have all done the problem like this before, many, 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 many times, okay? So when we're doing long division. So when I say long division, I mean the little house, right? The little house like that. Okay, that's what I mean by long division. So what goes on the inside? 370, right? The first guy, right? The first guy always goes in the house. So 373, and then the second guy comes second. Okay? That's the first thing. The second thing, all right? We try to match 6 into the first 3, right? We try to say, how many times does 6 go into the first 3, right? That's the first thing we do. We say, this guy on the outside, how many times does it go into this guy here, right? And it doesn't, right? 6 doesn't go into 3. It's too big. So sometimes you skip that, or some teachers had you put an X there, you know. And then the second step, right, was, okay, since it didn't go into 3, it goes into how many?
It could go in 6 times for 36.
37, right? And if it's 6 times to go 36, right? So we said it goes here, it matches this. I can make it match this or come very close to it, right? I can make 6 match 37 using multiplication. As close as I can, right? So we put a 6, right? We put a 6 here. And then what did I do? Multiply, right? I multiply, right? 6 times 6 makes 36, right? And then you subtract it, right? Right now, 36 is not positive. Or sorry, it is positive. It's not negative, right? So you got to do the opposite, which is subtraction, right? And then you subtract and make 1. But then you drop down to 3 and do it all over again, right? So now you got to figure out, how do I make this into this or come very close, right? So what can I use using multiplication to make 6 into 13? Multiply it by 2, right? Multiply it by 2. And that'll make a 12, and we do it all over again, right? Do the opposite, means subtract, because 12 isn't negative until I make it negative, and make a 1. And then some teachers, as you got better, right, you put decimals and zeros here and kept going, right? We're not going to do that today. That we're not going to do today. So tell me what else I can do with the 1. Besides make decimal, put decimals, and put zeros, which we're not going to do today, what else can I do with it? It's a remainder, right? It's called a remainder, right? Sometimes, don't write this down. When you first learned about it, you put remainder 1, right? Yeah. When you learned. And then you did decimals, right? Does anyone know anybody? There's a third way to write to do with the remainder. Does anyone remember how to? So the third way, which is the way we're going to do it today, is we're going to take the remainder and make a fraction. The remainder goes on top. This guy's called the divisor. The divisor goes on the bottom. So in other words, this answer is 62 and 1/6. 62 and 1/6. That's what we're going to do today. All of those steps that I just did, you're going to do today on every single problem. There's not one step that I did here that is different. That's why I didn't put any steps on the board. Usually I put steps on the board, but you guys have been doing this since 4th grade, so I didn't want to put steps because you guys already know, right? Some of you are like, I know how to do this. Good. Because if you really know how to do it, if I change it up a little bit, you should still be able to know how to do it. That's the definition of knowing how to do something. It's when someone changes it a little bit and you can still do it, then you really know what you're doing. Okay? All right. So, before we get into ours, let's try this one. Let's go over the steps one more time so that when we get down to our problem, we know. So we build the house. 459 goes on the inside. 3 goes on the outside. And then we start doing, right? I'm using multiplication as my weapon. I try to make this guy into this guy using multiplication. Multiplication is my only tool I can use. 3 goes into 4 one time, right? So we put a 1. Then I multiply 3 times 1, and I make 3. Opposite. Bring down what I haven't used. Well, 3 doesn't go into 1, but it goes into 15. 5 times, right? So I do that again. And then I bring down the 9 I haven't used yet. 3 goes into 9 3 times. Subtract 9. And I got a remainder of 0. No remainder this time. So what do we call 3? 3's got a special name. Over here, 6 had a remainder. So what do we call 3? 3 is a blank of 459. Starts with an F. Factor. It's a factor, right? How do we know it's a factor? No remainder. So let's write that down because they're going to ask us today, is it a factor? The way we know things are factors, factor equals no remainder. If you get no remainder when you divide, it's a factor. So 3 is a factor of 459, but 6 is not a factor of 373. Okay, because they're going to ask you that question. Is this a remainder? Or sorry, is this a factor? Well, how do we know it's a factor? Because of the remainder. Is there a remainder? Okay, all right, so enough of that. Let's go to our problems now. So our problems, the hardest thing about our problems is the intimidation factor. You look at something like that and you're like, oh my gosh. It's the same steps we just did. It's the same steps we just did. It says long division. Okay? So long division involves a house. The house is going to be a little bigger because it's a polynomial, but besides that, it's about the same. The first guy goes inside the house, right? 6x cubed, 6x cubed plus 11x squared plus 24x plus 7. The second guy goes on the outside. Right? That was our first step for A and B. This is going to be our first step for this guy. Haven't changed anything so far. It looks different, no doubt. It looks different, but it's the same steps. So once I did that, I tried to play the matching game, right? I tried to make 6 into 3. Didn't work. I tried to make 6 into 37. It worked a little bit, right? I could put 6 here. I tried to make 3 into 4, right? That's the same thing I'm going to do, the matching game. So how do I do the matching game here? Well, you're going to try to match these guys. You're going to try to match the first guy with the first guy. You're going to try to match using multiplication. Can I match the yellow guy with the green guy? Yeah, I can, right? So let's start with a number. What am I going to multiply 3 by to make 6? 2. So it's going to be 2. How many more powers of x do I need to match? 2. 2x squared. So I'm going to put my x squareds over my x squareds. So it's going to go over here. Because I like to keep everything lined up, right? X squareds, x's. So the reason I put 2x squared there was because the squareds were right here. Okay? So again, how did I choose 2x squared? Well, 3 times 2 makes 6, right? Matches. How many powers of x do I need to match this guy? 2. That's why I chose 2x squared. Okay? So once we got that number on top, then we multiply. Then we multiply, just like you did earlier. What are we going to multiply? I'm going to multiply this guy by this guy. Well, it's a binomial over here, so I need to multiply twice. Okay? So the first thing I'm going to do is multiply this guy times this guy. What do I get when I multiply 3 times 2? 6. How many x's am I going to have total? 3. So I'm going to put that right under here. This should match. Because we wanted it to match, right? We said we wanted it to match. Now I'm going to multiply this guy times positive 1. What did I get when I multiply this guy times positive 1? The same thing, right? 2x squared. Positive 2x squared. And then what did I do after, with the first two problems, what did I do after that? Subtracted, right? Didn't I subtract? So we need to subtract these two guys. Right now they're positive. So I'm going to make them subtraction or negative. Okay? This is the part right here where it trips most people up. When I'm helping at someone and they are making mistakes, this is usually where their mistakes are made. They forget to change the sign. Okay? So 6x cubed minus 6x cubed, 0, because they match. So we can cross these guys out. 11x squared minus or plus a negative 2, right? It's the same thing, subtraction. 11x squared minus 2x squared, 9x squared, right? The x squareds don't change. They stay the same. 9x squared. Bring everything else down that you haven't used. Positive 24x, positive 7. Do it again. Matching game again. How do I make the yellow into the green? First start with the numbers. How do I make 3 into 9? Positive 3, right? So I'm going to go right down to positive 3. How many powers of x am I going to need? I need just one more, right? I have one, I need another one, so it's going to be just x, 3x. Multiply. 3x times 3x, 9x squared. Three x times positive 1, 3x. Anything times positive 1 is always just going to stay the same. Don't forget about the next step, opposite. So if they are positive before, we're going to change them to minus or subtraction. Okay? 9x squared minus 9x squared, 0. They match. So if you subtract the same thing, they should disappear. 24x minus 3x, 21x. Bring down the 7 I haven't used, the positive 7 I haven't used. Matching game. How do I make the yellow into the green. Just a 7, right? Just a 7. No x's, just a 7. Plus 7. 7 times 3x, 21x, right? I'm going to write that underneath here. 7 times positive 1, positive 7. Opposite, opposite. 21x minus 21x, 0. 7 minus 7, 0. Done. So what is your answer? Your answer is on top. Doesn't have a remainder. So it's a factor, yeah. So if they ask you, is 3x plus 1 a factor of 6x cubed plus 11x squared plus 24x plus 7? You would say yes, it's a factor. It is a factor because I got a remainder of 0. That's it. Okay? That's long division. That's polynomial long division. We're going to do some more practice, but essentially that's it. Okay? Essentially, that is it. All right? So example number 2. If you're kind of getting this, you can go ahead. I don't mind if you go faster. I don't want you to go slower, but go faster. If you want to go faster, you can. Okay? Yeah, you got to do just send me a request. Okay. All right, so first thing, build the house. Put this guy in the house. Put this guy in the front. Go ahead. Okay. Matching game. Yellow into green. All right, first guy into first guy. We want to match first guy into first guy. So the yellow. So we already got 1s, right? Because there's a 1 in front of x and there's a 1 in front of x cubed. So we already got 1. So I just need x. How many powers of x do I need? 2. So I put it over x squared. Multiply. X squared times x makes x to the third. 1x to the third. X squared plus times 2 makes 2x squared. Don't forget to change the signs. Since they're both positive, now they both become negative. 1x squared minus, 1x cubed minus 1x cubed makes 0. 1x squared minus 2x squared makes a negative 1x squared, or a negative x squared. Bring everything down I haven't used. You got to match. Okay, yellow to match green. Now I need a negative 1, right? And I need a power of x, just 1. Multiply. Negative 1 times positive 1 is 1. X times x is x squared. Negative 1x squared. Negative 1x times 2, negative 2x. Right now they're already negative. It doesn't matter. You still got to change the sign. You still got to change the sign. So if I was to put a negative there, wouldn't it essentially make it positive? It's already got a negative. So since these guys are negative, I got to change their signs to positive. Always, always, always change the sign. So now you have negative 1x squared plus 1x squared is 0. Negative 10x plus 2x, negative 8x. Bring the negative 16 down. Okay. I got to make 1x into negative 8x. Well, I don't need any powers of x. I just need to multiply by negative 8. Negative 8 times 1 is negative 8x. Negative 8 times 2 is negative 16. They're both negative, so don't forget to change the sign. When I'm doing this, so when I'm doing it on paper, right now I'm doing it on my iPad, so I have different colors. But when I'm doing it on paper, I try always to have a different color. So if I'm doing it in pencil, I try to have a pen with me just to remember if I did it. Because sometimes when you do it in the same color or the same pencil, you forget if, oh, did I change the sign or did I not change the sign, you know? So sometimes when I'm doing it, I'll use a different color pen to do this, just to remind myself, because that's the biggest mistake I see. In all of this, the biggest mistake I see is forgetting to change the sign. Because sometimes you see a negative and you're like, oh, it's already negative. It doesn't matter, you gotta change the sign, okay? These guys go away because they're 0, these guys go away because they're 0, no remainder. So what do I put into delta math? This guy right there. That's what you put into delta math, just like that. You're done. Okay. All right, so the next two, we're going to get remainders. I'm giving you a heads up. The next two, we're going to get remainders. Actually, you know what? Let's skip number 3 for right now. Let's go to number 4. If we come back, if we have time, we'll come back to number 3, but for number 4, I want to go do number 4 right now. Okay. Build the house. Says use long division. The first guy is 12x to the 4th plus x to the 3rd minus 4x squared plus 17x minus 10. And then on the outside is 4x squared plus 5x minus 5. So the inside looks the same. The outside is a trinomial. We've always had binomials. It's not going to change anything. It's not going to change anything. We're still playing the same game. Okay? We're still playing the same game that we did on the last 2 examples. Okay, got it. Okay. All right. Okay, so first guy, match the first guy. First guy, match the first guy. Still got to do that. So using multiplication. So 4 times what makes 12? 3, right? So I need a 3. And how many powers of x do I need? 2. So a 3x squared. Okay. Multiply. 3 times 3 makes 12. 4 powers of x, x to the 4th. Next one. 3 times 5 is 15, x to the 3rd. So positive 15, x to the 3rd. 3 times negative 5 makes negative 15, x squared. Change the signs. 2 of them are positive, so they need to become negative. 1 of them is already negative, that needs to become positive. The first guy should be 0. If you did your job right, the first guy should be 0. Okay? 12x to the 4th minus 12x to the 4th, 0. 11x to the third minus 15x to the third, negative 4x to the third. Negative 4x plus 15, positive 11x squared. Move down, move down. Okay, new guy to match. So to make 4 into negative 4, I have to multiply times negative 1, right? I need to multiply times negative 1. And I need 1 power of x. So negative 1x. Or just negative x. Multiply. Negative 1x times 4x squared is negative 4x to the third. Negative 1x times 5x, negative 5x squared. Negative 1x times negative 5 makes positive 5x. Change the signs. 2 become negative, or sorry, 2 become positive because they were negative before, and 1 becomes negative. Subtract. Subtract, in this case we're going to add 11 plus 5 is 16, x squared. 17 minus 5 is 12x. Bring down the negative 10. Match. 4 times 4 makes 16. I don't need any x's. 4 times 4x squared makes 16x squared. 4 times 5x makes 20x. 4 times negative 5 makes negative 20. Change the signs. Negative 8x plus 10. So yeah, how do I know when to stop and how do I know when my remainder is? Well, let's keep doing. I'll show you. There's an easy way to tell. You'll be able to tell very quickly if you can't go anymore. Can I match 4 into negative 8? Yeah, negative 2, right? Can I match x squared into x using multiplication? Can I go down in power? No. I can't multiply this guy, right? Once you hit that spot, once you hit where this guy can't become, it's usually with the powers. I can't go down in power. I can stay the same power, right? This guy went up in 2 powers. This guy went up 1 power. This guy stayed the same power. But this guy would have to go down in power. I can't go down in power. So once you do that, you know you're done. So what do I do with that? That's your remainder. So we're going to write it as a fraction, just like I told you guys earlier. So we're going to say plus. You're going to put a plus here, plus the remainder. So we put negative 8x plus 10 on top, and you put the divisor on the bottom. The divisor is the guy in front. 4x squared plus 5x minus 5. That's your answer. That's the remainder. That's how you put it exactly like that into delta math. 3x squared minus 1x plus 4 plus the remainder, which is a fraction. Okay, this one's not This one is not a factor. Okay. All right, we're going to do, so we'll do one more because number 5 is a little different. Number 5 is a little different. It's not, it's just different question. It's the same thing we've been doing. So number 5, they just want the remainder. They just want the remainder. That's all they want. So how do you get a remainder? You divide, right? The only way to get a remainder is by division. So let's set up our house. Does anything look a little different about this one? No, we've done that before. Is there anything different about this one than any of the other 3 that we've done so far? What's different about it? Yeah, there's a bunch of missing stuff in the middle, right? There's a bunch of, it goes to the x to the 4. Usually we're used to seeing x to the 4th, x to the 3rd, x squared, right? That's how we saw it. We skip a bunch of powers. So my question is, in division, is that okay? So here we go. I'm going to give you an example. Let's say we have 4. And I want you to divide it into 28. Right? Oh, 7. But I'm like, oh, guys, I forgot. I totally forgot. It wasn't 28. It was 2008. That was the actual. I wrote the problem down wrong. Is that going to change your answer? Yeah, right? It's the same thing here. It's got to have things in between. You got to have placeholders in between, or else it changes your answer with division. Okay? So how are we going to do placeholders? Well, use zeros. Zeros are placeholders. So this is how you're going to write it. We're going to move this 5 all the way down. So we need an x to the 3rd, right? I need an x to the 3rd. So I'm going to use a placeholder. 0 x to the 3rd. Oops, let me use different colors to show that I'm adding this part. 0 x to the 3rd. 0 x squared. 0 x. Those are all the missing stuff. Because it's going to change my answer. Without those zeros, it's going to change my answer like it did this one over here. Right? Instead of 28, it was actually 2008. That's different. That's a lot different. So I need those zeros. I need placeholders. Okay? So in your notes, put placeholders. Placeholders in math are just zeros. That's all they are. But it needs to go in descending order when you're dividing. When you're adding, subtracting, you don't need that. But we're not doing that today. We're dividing. Okay? And then now, once you've done that, it's the same thing. Match this guy to this guy. It's the same game we've been playing the whole period. How do I match this guy into this guy? Three x to the 3rd power. 3x to the 3rd power. So I got to put it at 3x to the 3rd power. Then I multiply. 3x to the 3rd power times 1x is 3x to the 4th power. 3x to the 3rd power times positive 4 is 12. Positive 12x to the 3rd power. Change the signs, yep, change the signs. They're both positive, so now they've got to become negative. The first guy should disappear because 3x to the 4th minus 3x to the 4th is 0. The second guy is 0 minus 12. Negative 12x to the 3rd. Bring everything down I haven't used. makes negative 12. Well, I need a negative 12x squared. Multiply, multiply, negative 12x to the third. Negative 12 times negative 4 is negative 48x squared. Change the signs, change the signs. First guy should go away. The second guy, I get 0 plus 48 is 48x squared. Bring down the other guy. X, 1x into 48, I need a positive 48x. So I'm going to get a 48x squared. 48 times 4, 192. Negative 192x, bring down the 5. One more time. Negative 192. Let's see, 192 times 4, 768. Negative 763. So the only part they wanted is the remainder. So that's the only thing you'd put in delta math. You wouldn't put everything else in. That actually was one of the questions from the test I gave last year on the same chapter. I put it on here so that you would kind of get an idea. I like this type of problem because you have to do division to find a remainder, right? And you have to remember that you need placeholders, right? So that's why I put this one on here, because last year, it won't be a problem this year, but it will be. Did I do something wrong?
Yeah, the end, it should be positive, because you did minus 192 times positive 4.
Oh, so it should be, wait.
So you should just do 5 plus 768.
Plus, it should be plus?
Yeah, that's what you have on here, yeah.
Let's see. Let's see. Oh, yeah, it should be negative. Yeah, 768.
Yeah,
And then change it to positive. Yeah, thank you. So it should be 673. Is that what I got?
yeah.
Yep. Positive 773. Okay. All right. All right. So what I want you to do is two things. First thing, number, you could tape it first if you want, but that number 3 or that problem that we didn't do, I want you to do that one right now. Do that one right now. You can tape in first. You can wait to tape in, up to you. But I want you to do that number. I'm going to put the answer in the notes, but I want you to practice on your own doing that one. Number 3. Okay? You got it? Let me.